What's up? Good to see everybody again. We got a new guest today, Druba, also on the platform team, and our Cloudflare aficionado. But yeah, we got a lot to cover today, as usual. So we'll go right into it with the latest Cortina stuff. So yeah, Steven, if you want to take it from here.
Yeah, so Cortina 15 introduces the actual configurations required to enable Pebble DB to be run. So it's still kind of in an experimental mode, but as a little bit of background, Avalanche Go persists all of its data to a backing database. So it stores all the block data, transactions, UTXOs, accounts, things like that. And historically, that's always been written to a database called LevelDB, which, especially as of late, hasn't been particularly maintained that well. And I think while LevelDB used to kind of be the de facto standard for a lot of Golang blockchain projects, people are starting to move more towards PebbleDB. So correspondingly, we're kind of doing the same. So I think this version of PebbleDB still has a couple upstream issues that needs to be addressed. But we're just kind of playing around with it now and making sure that it's all good. So look in the future to see. We'll probably try to switch the default to PebbleDB eventually out of LevelDB and eventually deprecate LevelDB. But that's probably a little ways off. So that's kind of the namesake of this. We're playing around with these database backends. Patrick, I saw you on mute. I don't know if you want to.
Yeah, the unfortunate reality is that there's the LevelDB and PebbleDB disk formats are different. So, like to actually utilize PebbleDB, you do need to do like a full resync. And so we also had discussed maybe at some point having a migration tool that if your node is shut down, you can just like migrate everything over to a new format by like iterating over all key values in level. But people may find it easier to just resync. Yeah, and then the other question I have gotten about Pebble and like, okay, why are you doing this? Firewood. Yeah, so Firewood would be a drop-in for like some of the aspects of this, particularly like the state Merkleization pieces that have like MerkleDB based on top of PebbleDB or LevelDB. But for the node, we still need like a generic key value store to support arbitrary metadata that we may need to fetch at any particular point in time. So even with Firewood, you want some sort of fast backing store. We're also working on like a separate kind of approach to this, which kind of writes out some of these key values into flat files so that they're not actually stored in an LSM tree themselves because of the compaction overhead from copying stuff around. But I would consider that more work in progress at this point. And so not much to go on there. But from this perspective, yeah, Pebble is interesting. We've been using it in the HyperSDK for about the last year. And I really liked its performance and stability. But I know that the Geth team has been testing it out as well. And they have run into a number of different issues that they've pushed fixes upstream and helped out there. And I think we're a bit behind on that. So yeah, fun to play with. Don't use it in production yet. We maybe should have added a warning that said you can't use it on mainnet. That in
I mean, you
hindsight would have been a
can.
good. That's what I'm saying is we maybe should have not allowed that. But yeah, long
Yeah.
story short, yeah.
At own risk, use it own risk. Another thing that I think we should probably point out, I think this was actually one of Druba's contributions as well, was the base TX support to platform VM. So this is also related to an ACP that is currently live, I believe. It is being drafted right now. But essentially the idea here is that we've had a long kind of history of people needing to have some form of fund transfers on the P chain and needing to do kind of these very odd backwards transactions to actually be able to transfer assets just on the P chain. So yeah, we'll be kind of pushing for that as an ACP, and hopefully that gets adopted as time goes on. But I think as far as the code goes, it's very simple that and is actually already included inside of Avalanche Go, hidden behind a feature flag pending that ACP. So That's a really cool addition in Cortina 15 as well. Yeah.
Yeah, if Drew ever finishes that ACP,
I'm working on it.
yeah, that's a big common ask people have had, and I think it'll become a much bigger ask as elastic subnets start to happen more so on the P chain, because you'll get your staking rewards, but currently to transfer them, you have to like use an ugly hack where you like export something to atomic, which is not what should be going on, or you have to actually bring it to the X chain or C chain and then bring it back. So it's going to be much better that you can actually just move funds around. This is also a big request we've gotten from custodians that only operate on the P chain and they only want to support staking, that like they have to, that it forces them to integrate with at least 2 chains to do simple transfers, which is again, like very suboptimal here. So it's just a no brainer. The original intent here was like to minimize non-staking related traffic on the P chain. But at this point, like the traffic is there, and now it's just kind of going through like an suboptimal format. So you kind of got to do what you got to do.
It's actually introducing even more load, because it's like an export and then an import rather than just a simple transfer. So yeah.
I think the first party Avalanche Go wallet creates a subnet every time we do a basic transfer, right?
Yeah, I mean, yeah, it's not ideal. That's really not ideal, because that's expensive.
Yeah. So I mean, like a lot of reasons to clean this up. So I think that'll happen. Yeah, hopefully this ACP comes across. I think it is a no-brainer change. So yeah, and I think I think this the slight digression here, which is into like some people have also asked, like, you know, with delegation, like there's been a lot of community conversation about potentially changing like the min delegation amount and min validation amount. And I think what we've seen in other networks that like get too draconian with these things is that like it just drives more people to liquid staking, which is much less secure than just like native protocol staking. And so I think this is like a microcosm of a similar effect, which is like, if there's some way to do what you want to do on the chain, people will find a way, regardless of what is codified in the chain itself. I think one thing though that helps a lot the P chain is that there is not smart contracting on the P chain, so it's much more difficult to like implement things that entirely circumvent some of the protocol design. So, but that's a whole conversation we could go on for a long time. Yeah. I think the last one that may make sense to touch on is another ACP that's also going to be up there, which is that app request failed proto. If you remember that, yeah.
Yeah. So currently there are flows where the node will not respond to messages. So essentially, you know, imagine some VM introduces a new in the most recent case, a new like mempool request type. So we added on the C chain a request for like basically give me any transactions you have that aren't in this Bloom filter as like a pull gossip mechanism. And for nodes that did not support that, they kind of just dropped that message. They were just like, you know, I don't know what this is, like move on. And essentially what we're planning on doing is trying to guarantee that any request from a virtuous node should be always responded to. And there are going to be cases where you have, you know, maybe some node that does not support that message type, but that node should still convey that information to the original requester. So we're adding in kind of explicit like failure to handle messages, which will be a response. So this just added in the message like format. It doesn't add in any handling of that new message or anything like that, but that'll be proposed as a ACP as well. Yeah. So that's a very minimal change. I think the last thing probably that we want to talk about is some additional C chain tracer API fixes. These kind of seem to just come up all the time, which some of them are us, some of them are upstream Geth, and I'm not exactly sure how we can like prevent this kind of behavior. I think that the tracer is just kind of like fundamentally like not super rigorous. It's basically separating the API versus like the critical computing base. Like the tracers are definitely not in the critical computing base, but I don't know, Aaron, if you have any kind of.
Yeah, I mean, these things, most of these fixes come from upstream, and sometimes our changes have introduced bugs in them as well that cause them to crash. But usually the ones that come from upstream are caused by some unexpected behavior, some path that hasn't been explored yet. So, for example, there might be some opcode that requires 4 arguments and somebody doesn't specify all of them. So it's like a stack overflow or underflow issue, or a stack overflow underflow issue that causes, the tracer assumed that anytime this opcode gets called, it would have correct arguments. And usually it's some error like that where somebody's calling literally an opcode in the EVM correctly, that error doesn't get handled. So that's one specific example that's been in the past couple. I think actually this one, if I recall correctly, and there's a decent number that come up. This was like a insufficient, or it was like a memory, something to do with not sufficient memory that it was referencing, and it didn't copy it correctly. So, it's usually these edge cases where somebody is calling the EVM incorrectly. I'm not sure if it's triggered. It's probably triggered by somebody writing UL code or assembly or something like that and handling stuff incorrectly, or it could be somebody actively trying to cause issues that come up. Not exactly sure, but it tends to come up around the time when people are doing non-standard things with the EVM, that these tracers that typically only handle the expected path. And, these things have a decent number of regression tests. And also, you have the whole history of the EVM that usually they pass on most of, not quite all of sometimes. And it's when you do something a little bit more unstandard that those tests fail to catch it. And then there's some regression or a new bug that gets found.
Yeah, and people would say like, well, why is this even a big issue for different people? Well, most indexers will iterate over each block and fetch the logs, the receipts, as well as the traces. You need the traces typically to figure out actually the full like execution of everything that happened in the contract that may not include, like it may include things that are not exported by logs. Like logs are exported by the smart contract as it wishes to help indexers. They may not even be correct, right? Like you could have like a fake ERC20 contract that emits like transfer happened, but no transfer happened. But like every indexer would say like transfer happened. So this is a big thing that came up a lot at Coinbase when we were like trying to integrate different EVMs or like build a standard tracer, was like you could have a deposit to Coinbase like within any sub contract call, and you needed to understand if that ever happened. And without a tracer, you have no idea whether or not that happened. So yeah, it's super useful for different things. And if you want to explore more of that, actually, I shout out to Tenderly. I think they have like one of the coolest like trace explorers there is for the EVM in terms of playing around. But we're thinking about a lot of these things as we're working on the HyperSDK mechanism. And so like one of the discussions has been having like a standardized token subsystem underneath the virtual machine so that you can trace and track all transfers across all contracts as like a first party feature. I think Move does this to some degree. Not something that the EVM ever attempted. And I think that there's a lot of trade-offs there. But at least lately, I feel like the the pros outweigh the cons in terms of those trade-offs for reasons like this. Yeah, that's another super long conversation that we should probably put a pin in and have at a later time. Anything else you guys want to discuss on this release? Cool. I know the other one, which is maybe something I think that would be worth touching on for just what's going on, is 2171 around the nullable option in the codec, because we wanted to have like handshakes to talk about version upgrades or like network upgrades. So maybe Aaron, you can give a little context on like what that's about.
Yeah, sure. So the Avalanche Go codec has since the beginning not allowed you to specify an empty value in a struct that you're serializing or deserializing. And we wanted to add support for nil options because in Subnet EVM, we have all of these configs that allow nil values, for example, for like an empty list or a timestamp that's not specified, whatever it may be. And we wanted to support serializing those and didn't want to implement a completely separate codec. We wanted to reuse the Avalanche Go codec so we could minimize how much we had to actually develop. So we added support in Avalanche Go in order to have nullable values. And the reason that we want to do this is because in Subnet EVM, we have developed this ability to have sort of on-the-fly or programmable upgrades to activate certain precompiles or perform different state upgrades at a given block timestamp. We wanted these to be as configurable and easy to use as possible for all of the different people who are using Subnet EVM. So if you're thinking about something that is not Subnet EVM like the C chain, typically what we do in order to activate an upgrade is we actually hard code the time at which that occurs. But when we are talking about using Subnet EVM, which is used across a lot of different subnets and has a couple of plug and play features, like all the different precompiles that we've developed, that some people want to enable at different timestamps, some people may want to enable with different parameters and disable at a different point in the future. We actually want to allow people to do that by just specifying a JSON config or some sort of config value that says, activate this feature at this point in time with these parameters or deactivate it at some point in time. And the problem that comes up when you do this is that you have to coordinate all of the validators have updated to that exact thing. And so with Core ETH and Avalanche Go, when we actually activate an upgrade, Avalanche Go specifies a minor version bump. And so at the very networking layer, it will actually disconnect from validators that are a version behind so that it's not talking to anybody unexpectedly. And this makes it very, very easy to reason about what types of network upgrades have happened. And so we can very easily show up in the logs, there's a future version that is going to cause you to disconnect. You should update. You can have different health checks, different metrics about this. That makes it much easier to reason about. But for Subnet EVM, because you can have these network upgrades that don't necessarily require a version bump because they're actually plug and play and you activate them by just specifying this config value, you can have different nodes that are in the exact same Subnet EVM version, let's say V057. And if two different node operators have supplied two different values that say this network upgrade is supposed to activate at timestamp T, and this one is supposed to activate at timestamp T+1, you could have those two node operators have actually misconfigured the nodes so that when timestamp T happens, one will activate the upgrade and the other one won't, or the other one may just not have that upgrade enabled at all. So you won't actually know in advance that the nodes in your network have actually been configured differently. So that when that timestamp occurs, some are going to activate these new rules of consensus and others won't. And this can be a really big problem if you don't know about that this is going to happen. And so this creates this coordination problem where you have to announce your network upgrade, which we have to do for the C chain and Avalanche Go as well, and coordinate with all of the validators. It's just that in Avalanche Go, we typically have better insight into whether or not people have applied this correctly. And so it's a bit more dangerous and difficult, or not dangerous, but just a bit more difficult to do this with confidence with Subnet EVM because it doesn't have that very clear demarcation line with minor version updates.
Yeah.
And so what we're trying to do here is have an actual network level handshake for the VM talking to each other to basically say, here's the network upgrades that I've activated. And everybody in the network, all of the different nodes can actually do that handshake. Say, no, yes, I have the exact same network upgrade specified as everybody else in the network. Therefore, I'm totally good. Or it could specify, I've actually activated this network upgrade set to activate at timestamp T. And then some other people could say, I haven't actually done that yet. And then you can do some sort of math or some sort of formula to basically say, oh, 67% of the network has updated to this, 33% hasn't. I should be very concerned. I need to update my node. And you can have very clear metrics as node operators, as subnet maintainers, that exactly what percentage of your network has updated correctly. And what percentage has not, as well as for an individual node operator to get notified, have some logs, have some metrics that are standardized that say, oh, I'm actually a version behind, I need to apply this upgrade, and just making this entire process significantly more transparent to sort of mirror the process we have for doing these minor version upgrades that very clearly communicate it. It's still a coordination problem to actually establish these network upgrades and do them at a specific point in time, but this makes things significantly easier and just adds more transparency to that whole process. Another interesting thing is how some other networks do this instead of actually having every single node update by supplying a value, is they actually perform these updates on chain by specifying their runtime that should be used, or even including like a WASM blob that gets updated on chain. And as soon as a certain portion of the network has voted for it, then they can actually just update the WASM blob or the runtime that they're using so that they can do this on the fly without every operator actually performing the update to their software itself, which is a really cool way of doing things. And we're also thinking about enabling this for individual smart contracts as opposed to the entire network level by using Avalanche work messages and basically what we're calling off-chain Avalanche work messages to specify some section of the network has actually signed this update, which basically says, hey, I'm willing to update this contract to this, or I want to update this base level contract. And then you can actually perform an update on the fly of update this contract here, which will allow you to have validator specified updates of individual contracts, which is a really cool functionality, especially for app specific chains that want to have that type of functionality without actually necessarily updating the entire execution runtime, just for an individual application. So a lot of cool stuff here. And the big thing to remember with this is just that we want to improve the transparency around these network upgrades for subnet EVM and mimic exactly what Avalanche Go already has by just bumping the minor version update.
The one small teaser I'll put in here too is like, I know we've already talked about this one a lot, and we'll move on really shortly, but the thing I'd really like to see is using something like this to actually trigger activations of like based on stake readiness for different things, which I see Steven's face, not in total agreement on, but like I think the coordination of setting times and then trying to push everybody like update now, like the time is coming, and instead having like a stake readiness thing based on like what versions people are running on and like what they've activated is a much smoother way to activate these sort of upgrades. And so I think what would be the next like step here for a lot of this stuff is once you have the ability to communicate like what everyone's doing and like what percent of stake is running what, that we could adopt that functionality to say, yeah, instead of specifying a timestamp, specify a percentage stake. And then after X, minutes or hours or days of like hitting that threshold, that the network activation locks in for a particular time. And then it's just automatic. I think one thing that people may not realize is because like everyone that's running on Avalanche in a sophisticated way is like launching their network, we've gotten into this cycle where like we're just super optimizing around networks and creating new blockchains. And so I think we're focusing a lot of energy on stuff like this in ways that other groups probably aren't because they just don't have to. But I think that from that, I think a lot of the learnings of like making it easy to manage a blockchain network should percolate back into the core Avalanche network, I would hope. So this would be one of those examples.
Yeah, the thing that's like so interesting about it is like if you do something kind of like just in like the P2P
Flippy
network. Yeah, like if you do something just in like the P2P network with like flagging of whether or not it's enabled or not, you can get into these really like weird cases where like some people think that they saw enough stake, so they're like in on activating, and then others like haven't yet. So like you probably want to have some more thing closer to like an actual consensus step where you're saying like, hey, like I got signatures from like sufficient number of people, like I'm updating, and here I can prove to you that you should update as well. But then it's like, okay, like, do you want
Did you
to
say
like,
BLS multi-signature?
Well, I mean, you could do that, right? But then it's like, all right, is that going on like the P chain? Like, because like oftentimes these upgrades end up getting coordinated across like multiple chains, right? Where it's like the P chain's upgrading and the C chain's upgrading and the X chain's
I think
all
it'd
at
be
the
by
same time.
validator set, right? But posted on
Well,
the chain, I guess.
like perhaps, but like when is it activating concretely on like the C? It's just like it gets into these like really weird edge case things where like as a system designer, it's like I am not very happy with like a protocol that works 99.9% of the time. Like I very much want to like be like, all right, I understand exactly how this works, and like we're good to go here. And it's just it's a complicated step. It's very easy if you say update by this time, and then you just say like that's it, and then like as long as you get enough nodes updated, then you're good to go. And like it's very easy for us to monitor the adoption of that. And so if we were ever concerned that the adoption is sufficiently high, then maybe we push out like another emergency like version to delay the upgrade or things like that. Like, those are things that, are pretty well understood and that like we currently have as options. But if you like try to like programify it, then it gets can get hairy. Anyways,
the death of automation is complexity, right? Like, oh shit, we just tore down the entire environment. Like, but it only took one command. But yeah, that's Cortina 15. Let's go into the next topic, which is ACP-13. So first ACP was posted. I'll drop the link here in the chat for Kyle to share in the comments. This was after a bunch of feedback from the community, which I still haven't finished responding to. So for people that are still waiting for stuff, I have not forgotten. I think there's a huge backlog of questions about Avalanche, the network, and like the topology of it that are just lumped into this. And so they're all good questions, and I'm just trying to get to them as I can, while still balancing like HyperSDK work and everything. The stuff I added to this post the initial community conversation was better specifying what exactly the initial ACP was for. So like the blog post, I think, or like the idea post was pretty, it implied that like agreeing to like work on ACP-13 was the equivalent of agreeing to like every single step there, even though like step 2, which was the pay-as-you-go stuff, and step 3, the augmented security, were very underspecified. And so I made it much clearer in this that like the initial change is actually pretty minimal. The complexity is more so the reason why the other ones were discussed, in my opinion, is more to just talk about like the doors that open up when we talk about separating some of this like forced primary network validation. But this ended up leading to like much longer conversations about, well, if we had this partial sync, should the whole thing be partial? Like, should we just take the X and C chain out? Like, should we, it opened up like the can of worms of a bunch of different directions, which I think are great conversations to be having. And I'm surprised, I guess, that we haven't had them earlier in like a clearer forum, but I guess that was the benefit of launching this repository from the foundation. So yeah, I think this brought up a bunch of things, and I really tried to highlight that it's specifically these set of changes, which is just the subnet only validation, and then changing basically the peer-to-peer network to support this sort of mechanism, and outlining, maybe what this could look like. I also spent more time talking about security considerations related to both like what risk we mitigate by going to this from the Avalanche Go, which is like we can have better separation of like primary network validators, which is good for everybody. Also talking more about the risk on the P2P network of having potentially many more subnet validators, query validators as non-validators, and what we may want to consider for that. The answer in the long term and for many of these is the more multi-signatures, the better. But I think that's a stepwise function. I think as we start to play around more with like performance on the P chain, we may come to the conclusion that like we just remove Oracle blocks entirely. It's just BLS multi-signatures. And then the benefits of that are so great that we try to kick off some sort of migration where people can maybe post signatures from their node cert onto the P chain with the BLS key that they're going to use if they haven't registered one. And then anyone that doesn't do that just gets I don't know, just that consensus way won't count, or maybe it's like a continuous process and that like there's a voting switch, and then if you don't activate by a certain time, you can like always do it later, but that old transaction type is deprecated or something like that. So but I think that multi-signature stuff solves many of the problems, not limited to even a big question people also asked was, I want to run my subnet and I only want to be on the subnet, so partial sync only, but I want to support teleporter messages or like warp messages from the C chain. Well, do I have to go like call out to some RPC if I don't want to run the C chain? And like the unfortunate answer is like, yeah, it's not great, but it's totally fixed if every validator produces like a BLS signature over accepted blocks on the C chain. Then you can just use that as like your oracle over any data you want to pull. So it totally solves that problem. So many of these solutions, like questions people have solutions based on stuff that's already pretty well implemented, just not widely utilized yet. And so I think you may see us in 2024 go all in on this sort of thing to better, I think, structure the network for what we want.
Finally deprecating the add validator TX.
Yeah. The downside of this, right, is that it requires like explorers to update. Well, actually, the transactions already exist, so not explorers, but wallets to update to use the new format. So yeah, I mean, but yeah, it was great to get the proposal out there. I think some stuff that needs more analysis is related to like what this refundable lock should be. I put 500 in as a placeholder, but I think more analysis should definitely be done on like what the right value is there. generally my recommendation for situations like this is to start conservative and then go more aggressive over time as we like understand more of the function of the mechanism. The other characteristic that I actually realized was not in here at all is if there's any term. I never mentioned like a specific duration of the staking period. And so I think when we need something related to that, unless maybe I didn't, I just forgot, but maybe I included it in the lockouts with like reward locking, but that was a consideration that other people asked as well. So yeah, I think that's really on that front. But yeah, if you want to get involved, there's kind of two discussions. There's the original discussion that was in the idea section, which has a bunch of comments, and I basically wrote everything up and added it to like this blog post that I wrote, which you can check out here with all the open questions on it. And then the actual conversation, now that there's actually an ACP up, is here, which has still a bunch of unopened questions, unanswered questions. So yeah, that's the gist of that one. So I think I wanted to give a shout out to the GoGo Pool folks for inviting me on a week or two ago to talk about it in like still the proposal phase. And so that was a great conversation. So yeah, but now we got another ACP. So Druba, tell us what we got going on here.
Yeah, so taking a little bit of a step back, I think something to understand is that the Avalanche network uses TLS certificates almost explicitly in every case to attach a TLS cert to a node ID. The way that's done is you hash the TLS certificate, you get a 20-byte array, and that is then converted to a node ID. If any of you have done a staking operation or looked up the validator sets, you'll see like node ID dash some random string of letters and numbers. So those are the node IDs, and this is the way that we authenticate P2P messaging. So we explicitly rely on TLS handshakes to facilitate these communications. And additionally, for Snowman++, we need to authenticate which node ID is actually proposing the block. And because of that, we have them include the node ID itself and the full TLS certificate because it's a hash of the TLS certificate. This is obviously like pretty inefficient. The TLS certificate itself is pretty large and varies depending on how you generate it. By default, Avalanche Go uses a 4096-bit RSA private key to generate it. And after the TLS certificate is generated, it's persisted to disk. And because of the Snowman++ tie, every block in a Snowman++ chain includes a full TLS certificate, amplifying the block size. So concretely, what this changes is we will now support ED25519 as a supported signing algorithm for TLS certificates. Avalanche Go explicitly prohibits any signing algorithm for TLS certificates other than RSA and ECDSA. And since it's the predominant Avalanche network client on the network, that means the entire network does not support any other signing algorithms. So phase one of this will be to enable ED25519 TLS certificates. Additionally, we will probably want to cut over to just using the public key itself for node ID identification. This will make it a lot smaller in multiple regards. We no longer need to embed the TLS certificate in Snowman++ blocks. We can just embed a signature, an ED signature, which is much, much smaller. I think we have, so the public key is 32 bytes, as you can see on the bullet points. This private key is 64 bytes, and the signature is 64 bytes, which is a marked improvement from the current status quo. I think that's about it for the actual change. ED25519 is a pretty well specified cryptography library. The Golang standard library has an implementation. It's used very widely in the crypto industry and outside. So we feel pretty comfortable about this as a cryptography algorithm itself. The one very interesting part about all of this is the verification criteria. Patrick, if you want to scroll down to that section. So ED25519 and Henry DeValence, credit to him from Penumbra, and I think he was at Zcash when he initially wrote the article, but he has a fantastic article talking about exactly the problem space for this validation criteria. But the actual specification for ED25519 does not really have a clear criteria case for validating signatures. So there's a great article. It's all linked in the ACP if you guys want to read more about it. But basically, different libraries for different implementations of ED25519 specify different things that they validate. So if you have a signature, it may be supported and accepted by one library, and it may not be supported by another library. For Avalanche Go, this isn't too big of an issue for the Avalanche network in general because we kind of have one single Avalanche network client. As we continue to diversify clients, it's going to be very important, especially when you go cross-language, that the validation criteria is very clearly defined. So for this ACP in particular, we've chosen to go with the ZIP 215 standard, which is the same one that's proposed by Henry DeValence. And that will explicitly define the ED25519 validation criteria we will be using. So there's already a Golang library that does this, and I think it was done by the Oasis protocol, if I remember correctly.
Yep.
The HyperSDK already uses this library. Patrick can speak to its performance.
Yeah, the one other benefit of the ZIP 215 is that it opens the door to like batch signature verification over ED, which is super sick. And so for people that aren't aware, I mean, this is not my idea, nor is it my implementation. So like, I want to be super clear about that, but I benchmarked it and it basically shaves the verification time per signature by like 50% or more. And so on the HyperSDK, we put all of the signatures into like a single batch and then verify them, and then do that in parallel based on how many signatures there are to verify. So you kind of balance this trade-off of like still getting parallelism, but like making sure that each core that is actually doing the parallel work is like much more efficient than it otherwise would be. I think Solana is pursuing the same thing with like FPGAs, which is definitely a much more powerful instrument. So maybe we'll hit that at some point, but initially that doesn't seem to be the bottleneck, and that doing like batch verification seems to be all right for a while. I actually posted a question on the discussion for this ACP. I'm not sure if you had a chance to look at it yet.
I did respond to it. You may not like my response, but
so I posted, and I think this is a fair question. Should we try to find a way to just use BLS keys as opposed to having ED and BLS keys? And I know that there's a connection to TLS certs. I get it. There's definitely no BLS spec for TLS certs. But again, you don't need TLS certs to have mutually authenticated encrypted communication.
Yeah, so taking a little bit of a step back, I think just understanding what validators currently manage is important. So right now we have validators manage a BLS private key, a TLS certificate, and the TLS RSA key itself. So that's 3 different secrets. As Patrick mentioned, if we move to only using BLS, that'd be fantastic. Validators only have to manage one secret, which is BLS key. And decreasing the number of things you have to back up makes it a lot easier for node operators as well. As far as I can tell, though, there's no like specified authenticated communications protocol that just do BLS, and they're pretty slow to verify, and I think that's why they haven't been picked up pretty heavily amongst like the communication protocols. And unless you're aggregating signatures, they're not that much more efficient either. This ACP, though, does take into consideration that we want to reduce the number of things validators do want to or are required to manage. So we're explicitly moving from 3 different things: BLS key, the RSA key, and the TLS cert, to just 2 things, which will be the BLS key and the ED key.
All I'm saying though is like, wouldn't it be nice if it was just 1 key?
I mean, to be fair, right? Like if we actually wanted to, we could just like take the staking folder and convert that into like a staking JSON that has like all of the different things compressed into just one file that you have to back up. Like that might be a nice UX improvement regardless.
Yeah, I mean, to play devil's advocate to my own question, the other thing that may be nice is that if BLS keys are kept separate, like, and we know that they're not part of like the network handshake, like you could potentially in the medium term, like build out more tooling to like have more integrity checks around like the things you actually do sign with your BLS key. But if you have to keep it so hot that it's like part of every network handshake, like it's probably not a tenable solution there. It also opens up the door if you use a single key that like you can somehow via a bug sign something that ends up being useful for like a warp message or something like that, which you should hopefully get around by prefixing your like bytes. But nonetheless, go ahead, Steven.
Well, so this is so going back to the warp thing a little bit. Avalanche Go manages the BLS key, and then VMs will end up requesting Avalanche Go to sign things. So Avalanche Go does enforce that the message is prefixed with the source chain ID. So that is managed by Avalanche Go. Obviously, there could be a bug in Avalanche Go or something like that, but at least as far as the VM is concerned, the VM does not actually have the ability to sign arbitrary messages with BLS keys. So that's good. But I know that this ACP talks a little bit about the ECVRF stuff. And the ECVRF, if we were to try to go down that route with the ED25519 keys, we need to be extremely careful because the messages that you're signing for the ECVRF and the messages that you're signing for TLS, you have to be extremely careful against nonce reuse attacks, essentially. So this is, in general, this probably isn't like too big of a deal specifically with TLS because we require TLS 1.3 and TLS 1.3 has a very kind of static message that gets signed. And then the ECVRF also has a relatively like fixed message that ends up getting signed. But we might want to go down the route of explicitly introducing entropy into the nonce generation, either of the ECVRF or, probably of the ECVRF, if we wanted to like introduce that as well, which is slightly non-standard with ED keys to introduce that entropy. Because generally the nonce generation is deterministic with ED keys via the spec. But anyways, yeah, there's this proposal does not necessarily like dive into the ECVRF stuff, but if we were to do that, I think that that's a very nice addition that you can get out of the ED keys. But we have to be really careful if we want to use the same ED key across different protocols.
A super nice part
Don't
about
worry, we
all
can
of
just
this,
have
though,
another key.
the super nice part about all of this with EDs especially is because it's so widely adopted, there's so much security analysis being done on like all these different kind of use cases. So for example, with the ECVRF that Stephen just mentioned, that actually recently got specified and included in a formal IETF RFC. I've linked it in the ACP as well. So we're following the specifications. This is not something we're just kind of pulling out of a hat. So it's a very cool use case of it. This ACP specifically talks about moving from RSA and ECDSA to ED keys for the TLS certificates and using ED for the node IDs. The ECVRF is thrown in as a future work kind of application. In the spirit of consolidating things that people have to manage or trust, one thing we've seen a very common request from subnets is a way to generate randomness on chain. Typically, people use third-party providers to provide that for them. Being able to rely on your validator set itself to generate a VRF per block using the associated ED keys is a way to reduce your trust, or just do trust minimization around your system in general. You no longer need to trust a third-party provider. You're already trusting your validator set to generate the next block correctly. and continue moving the chain along, you can then trust them to perform a VRF. And as specified in the RFC, the VRF itself is, it is verifiably random and just uses elliptic curves, which is super, super sick. And in terms of the other open question I'd like to briefly touch on, we use TLS almost exclusively to do P2P communications by moving to a world where the node ID is no longer tied to a TLS cert, but it is tied to an ED private key. It opens the door to hot swap alternative communications protocols like Quicker Noise, which both can be used with ED keys. So we no longer need to reason about moving between or changing the link in the future, because we'll just be relying on the actual private key itself rather than a wrapper around it. I think Solana uses Quick and is experimenting that for some of their P2P communications. So for a high throughput chain like Avalanche, it may serve us well to move to an alternative communications protocol. But just to be super clear, for the alternative communications protocol and the VRF, neither of those things will be immediately enabled post this ACP. It is simply provided there as a way to understand what can be done in the future given this change.
Yeah, I bet you could use BLS with those too, maybe. I don't know.
I actually do think that we could use BLS for a VRF, because BLS is a fully deterministic signing and verifying protocol. It's actually probably significantly easier than the ECVRF. The ECVRF, you have to worry about all this like nonce like stuff, because like anyway, but like the BLS, from the BLS side, it's actually probably a lot easier, but it is less efficient and much less standardized than the ECVRF at this point. So it's a very interesting question. Like we could probably just use BLS here if we wanted to.
That's why it's a proposal, let's figure out the right way. Yeah, so you may be listening to this conversation and say like, wow, like there's a lot of stuff like that's going on. Like we have no idea how to track everything. We've heard you, and across all the different repos, we actually agree and struggle with the same thing. So we're working on revamping a lot of our like roadmap tracking of how everything is actually processed. And so I wanted to share a quick preview of some stuff we're playing around with. So if you've talked to anybody at Avalabs, or at least if you asked anyone at Avalabs, they would say I'm like a GitHub maxi in a lot of ways, but we live and die on GitHub. And so we're working on a new structure that basically will auto-populate a living roadmap with everything that we're working on based on like all this like cool tracking stuff that they've added over the past year. And so we're working on publishing all of the major initiatives that at least Avalabs is working on, and then linking the corresponding work, as well as like the target date for like when we hope to complete it in like a 3-week window, as well as like what we're actively working on. So you should be able to see pretty clearly like where everything is at, like what stage different things are at, like what kind of composes a particular initiative. And then across all the repos, like what's in flight. So like how many things are actually going on at once within like a particular repo, like where everything is at for a particular release, like all the different things and what's actively being worked on across all the different projects. So that's like the HyperSDK, that's the EVMs, Firewood, Teleporter, like tooling. This is all blank because it's really new. We're still playing around with some of the functionality here. It's not that we're not doing anything. And so if you want to get involved, there's another thing that we're doing, which is separating up the work by working group, we call it, which will allow you to, if you want to like more deeply engage with a particular type of work, understand everything that's kind of on that work stream at any particular time. And so through all of this, we hope to like better merge like the open process with like what we're doing internally, so that it's clear how you could contribute, and also to understand like what we're actually focusing on. So this is a big push of mine as like the have to be some of the non-technical person here, but to help better track like what's going on both for us and for everybody. But then you can get some cool charts and stuff too. It's like how many things are in flight, like, you know, are we doing more than we thought we were going to do? Why is that? And you can kind of track all this stuff. So we're trying to make something that, I think the big thing with a lot of teams is like, everyone's like, hey, do you have like some idea of like what you're going to be working on? And usually the answer is yes, like here's this document. And then 3 weeks later, it's like, well, document's out of date. So I think it's really important for this sort of thing that it gets merged into like the actual development process if you want to have any hope of keeping it up to date at all. So I also, so that's something we're working on. And I think as we get a little bit more solidified, we'll probably share a link out as soon as everything is fully included here. So and then I think the last one was discussing the HyperSDK address refactor. So this was something that took a bit to really figure out the right way to do. But I'm super happy with how it ended up. So long story short, when I was originally working on like how you were addressing like different things in the HyperSDK, I just used basically ED public keys as your address and was like, I'll figure this out later. Like when I have stronger conviction, because like all the best stuff initially was just ED anyways. It was the cryptography I wanted to use. But as we got closer to like actually launching programs, didn't really work out super well because programs don't have a ED key. And then other people actually asked some really good questions about integrating like SecP 256R1 keys, which again are not ED keys. And they actually even have a different public key, like a compressed public key length. So like you can't just like drop it in and pretend it's a ED public key. So I went through a lot of cycles about thinking about the best way to do this. And after like a lot of communication with Steven and some of the rest of the folks at Avalanche, came to the conclusion that the best approach was to basically define a new codec type called address and then use that everywhere and call that codec, basically that codec type being 33 bytes. The first byte being like a type byte, and then the 32 bytes that followed just being any arbitrary 32 bytes that the like auth module wants to use. Now, what this lets you do, for example, in the world of ED, is you can now just like basically hash the public key. And so then if you send to somebody, they won't know your public key until you actually use it on chain once, which is like really nice for a lot of people that are concerned about like all this like post-quantum stuff. Like that's the only reasonable defense against post-quantum stuff. But the more interesting thing is that you can actually hook up like programs to it and actually have programs have balances, because the auth module can just be attached to like some program or some address of some program in a token subsystem. So you can now basically communicate between arbitrary auth types as well as arbitrary like contracts that can have balances, but they're all universally addressable within the single HyperSDK addressing scheme. So this may sound like, oh, you know, how bad could it be? Well, I was using the expectation that it was going to be this crypto public key everywhere. So it was quite a slog to get this figured out. I ended up changing like 100 files, I think, and just ripping out every hard-coded expectation of the ED stuff. And then through that process, I also made some other cleanups. One I really wanted to touch on here was that previously, every auth module had this thing called a payer, and that was just arbitrary bytes. The payer was the person that like, or identity that like paid fees. So when a balance was checked in the mempool or like whatever like that, you just check this payer value. Now, anyone reading this would say, this looks jank. And I'm like, yeah, I agree. It does look pretty jank. So I changed that and now changed it to two separate things. One's called the actor and one's called the sponsor. The actor is the person that's part of any action, and like that's the subject of the transaction. The sponsor is the one that pays it or pays the fees for that. And they could be one and the same and they could be different. But the point here is that actions should be entirely unaware of what auth identity is actually invoking them. And with this mechanism, you can do that. So when a action is called, you no longer have to like actually parse the auth module, which is how it used to work. Like I still give you the auth module and the action so you can do whatever you want to, but really it should be entirely abstracted out, and you should just know like who the actor is in this particular case. And so that may be a future interface change, as I may actually entirely just remove giving the auth module to the action. But seems nice to kind of pass it along a bit still. There may be additional context so that people may want. But for most actions, and I've migrated all the actions in the HyperSDK, they just use these two things now, which I think makes it much easier to reason about, because previously all the actions had to like parse the auth, which was, again, iterations of making this cleaner as we get closer to production. So I think this was a really good change, and it unlocks the ability to play with arbitrary crypto. So over the weekend, I was hoping to actually implement the BLS signers for Morpheus as well, so that you can just use a BLS key directly as your identity, which would be pretty cool. Because then you could implement threshold BLS as like an owner of some token or something like that. So yeah. That's the gist. I think we're at the end of the call. I don't know if you guys have any other things you'd like to add here.
One thing I forgot to mention before is happy birthday to Druba. A little late, but
Thanks. I'm no longer 21, so that's good.
An issue now to make sure we do the BLS thing before I forget. Add BLS signing.
Almost like you're a fan of Dan Bonnet.
No comment. BLS is great. If it was quantum resistant too, like I think we'd solve world peace. Like that's how it'd be so sick. But like you see those memes where it's like
right
if
now.
only like blank, like then it's like some futuristic city. Like there's so much time and energy going into like how to migrate like the properties of BLS to like a post quantum like a security model. And it's like shit, if they just had that, like wow, that'd be cool.
If only the BLS distributed key generation was easier to like understand.
Yeah, as armchair researchers, we have a lot of comments about BLS. No, but it's great. So yeah, but yeah, thanks everybody for hopping on, and thanks for listening at home. I think the recommendation is if you haven't gotten involved in the ACP stuff yet, like certainly leave some comments and leave some discussions. Some of the ones that are going up now actually have much more implementation work already kind of specced out on them. So there's probably much more to engage with. I think some of them will go into like an implementable status pretty soon, which is basically saying comment period for like how the ACP scope could change is closed. Now it's time to implement and voice like clear concern for or against.
The next ACP you can look out for me is, I think, one that subnets are going to be super excited about, and it's being able to rotate the control key of the subnet. So that should be coming out hopefully by tomorrow.
That'll be controversial, I'm sure.
Yeah, the plan here as well too for people that are wondering like why are we at Avalanche spending so much time on like posting ACPs for things that seem non-controversial, and it's to get in the habit as like more clients and like more tooling comes online that there's like a clear record of any protocol changes that would need to be made by any set of clients, although right now there's just one. And so people are like, well, this seems pretty minimal, like seems entirely non-controversial. Like, why is there an ACP? It's so that anyone following along can understand how the protocol has evolved from its current specification, with the hope obviously being that the entire protocol is specified at some point in the future, which is not the case now. So yeah, hopefully that also answers that question, which I know a few people had. It's not to be pedantic. It's to get in the habit of making sure that all protocol-related changes are visible and debated. Yeah. Cool. All right. I think that's it. See you later.